Okay, so we just did a composition of transformations. We just performed one ourselves. Now we're gonna identify the composition. So we're given the final and the original. We have to say what happened. All right, so what happened to get from A, B, C, D to E, F, G? All right, so just realize like A has to map to E. Similarly, B has to map to F. All right, so on and so forth. All right, so let's just look at some lengths right here. Notice that this length is, let's just count it. What is it? 1, 2, 3, 4, 5, 6, 7, 8. That's a length of 8. This right here is a length of 4. So I know I already need to do some kind of dilation with a scale factor of 1/2. So let's just go ahead and do that first. Let's say number 1 is, let's at least just get the shapes the same size. 1/2 X, 1/2 Y. So I'm going to take all these points. So A is 1, 2, 3, 4, 5, 6. This is at 6, 2. So A prime is going to be at 3, 1. D is at 1, 2, 3, 4. So that's 10, 2. So that's going to be at 5, 1. All right, and then see, since I know that I had 8, I can just count up 4. I don't even have to figure out B. I can just figure out B prime that way by just counting, using a little bit of logic. All right, because remember, I am reducing all the lengths by 1/2, so I can do it that way as well. All right, so now I have 2 shapes the same size. Now I can tell that I need to rotate it somehow, because remember, this side corresponds to that side, so I can see it's going to be some kind of rotation. So I'm going to rotate. Now realize I'm just going 1 quadrant over, so it's going to be 90 degrees, and then I'm going counterclockwise, and then to be very specific, I'm going around the origin. So really, we can just figure out how can I get the shapes the same size, and then how do I get them oriented the same way? All right, so this is like the same thing, BCDO on HLKO. All right, so I can see that, let's do this. B is going to go to H. So B is going to go all the way down there. Let's just do another one. We don't have to do all of them. I could if I want, but C and L are also going to correspond. All right. So basically I need to make BCDO bigger and then make it upside down. All right. So let's just start with some very obvious lengths. This length right here is 2. This length right here is 4. So I know my first thing I'm going to want to do is enlarge my image by a scale factor of 2. All right, and if I do that, well, B prime is going to be up here now. C was at 2, 3, so it's going to be at 4, 6. These are a little blurry. And then D is at 3, 0, so D prime will be at 6, 0. And O stays right where it's at. You guys can hear my neighbor's dogs. They were let out for probably the first time this morning. They're just amped up to be outside, hear my math lesson. All right, so we have that image now. Now, a popular pick for students year after year is to say reflect over y equals -x. That's a good pick, but we're actually just spinning it around, and I want to spin it around upside down. I'm really just rotating. Rotate 180 degrees clockwise around origin. All right, and that would map these quadrilaterals onto each other. All right, so again, these problems are from the iBook. You guys can bounce to the iBook, do the problems that way. Challenge your, it's probably a little bit harder. You guys could always challenge yourself if you really want to invest, push yourself, get good at this stuff. I'd recommend doing that. Or if you just like being guided through, just continue watching this video. But we're going to determine the scale factor of the following figures and classify each one as a reduction or enlargement, and then you can tap the image to check your answer. You can only tap it in the iBook. All right. So remember the coordinate note or the prime notation is huge. We're going from A to A prime, so I know it's a reduction. And then this length right here is 12. This length is 4. So I'm getting smaller, so it needs to be 1/3. All right, that's how you do it. All right, and that was equal to 4 over 12, and I just reduced it. 1/3 is the official answer. I got a little excited and just wrote the final answer, but you just do 4 over 12, bada bing, bada boom. All right. In this next case, again, there's a lot of ways to do these problems. From A to A prime, it's getting bigger, so it's an enlargement. Now, these slanted lengths are kind of hard to count. Let's just look at the coordinates themselves. A prime is at -3, -1. Or A is at -3, -1. A prime is at -6, -2. So I can tell that I'm multiplying the coordinates by 2. So the scale factor would be 2 in this case right here. And then, same thing here. Look, we have a nice slanted line. I mean, that nice straight horizontal line. 2. That's a length of 1, 2, 3, 4. So I can already tell I'm getting bigger by a scale factor of 2. That's a really bad 2. We'll make it work. That's an enlargement. And that's it for that video. Stay tuned for the rest of the notes.